Hello, students. Am I audible?
Yes, sir.
So you are writing some fictitious lines on the PPT. Don't please remove them. Do not write any fictitious lines on the screen that I have displayed. Who is the class leader? CR.
Sir,
Who is the class leader?
302, sir.
Class representative.
I'm only, sir, 302.
302. Who has
Yes, sir.
drawn these lines?
Don't know, sir.
Please do not ask them, ask your students not to write anything.
Okay, sir. Okay, sir.
So, okay, today you might have seen the syllabus. So I hope that all of you might have uh, seen the particular syllabus of this operation research. And this is a little bit uh, difficult and confusing subject. A lot of practice and the problems is very much required. Unless you practice at your house, it is very difficult to understand the particular subject and difficult to expertise on this particular particular subject. So you are all aware that practice makes man perfect, and therefore you are all requested to practice the subject at your house, practice the particular thing on paper, this particular subject. So this is basically a starting one. It is an introductory subject, introductory chapter. Hence, uh, this regarding the information regarding this theoretical part, I can supply the PDF copy later. But anyhow, try to uh, concentrate and make yourself available throughout the particular class. So attendance is going to be monitored. It will be taken either at middle of the hour or at the end of the hour. Now, regarding the some students, it is observed that some students are uh, registering on the names. So I request all of you to register with their registered numbers. So therefore, it is easy for us to collect the attendance either at the middle of the session or at the end of the session. I request all of you to please comply with this particular thing so that it is easy for us, for the department or for the administration to record your attendance. The attendance has to be sent at the weekend. And further, the entire lecture is going to be recorded now. The video lecture has to be uploaded. Therefore, the attendance will also be automatically recorded. So later, there will not be any problems. To avoid further problems in the succeeding days regarding the attendance, I request you to all of you attend carefully. Do not leave in middle and do not join at the end like that. Okay, next phases of war. So formulating the problem, in formulating a problem for war, uh, we must be made of the four major components, that the environment, decision maker, objectives, alternative uh, course of action, and constraints. Uh, these are the environment means the prevailing situation of the industry. That is nothing but the environment. And the decision maker means nothing but the top boss. And objectives means the aims of the particular industry or goals of the particular industry, and alternative course of action and constraints. So if depends on the decisions, depends on the objectives, and depends on the environmental conditions in the factory, if a certain uh, problem failed to address the solution, then what is the alternative course of action? And within the framework of the rules and regulations, that has to be decided. So, so this is very much important. So this is the environment is very important, decision maker, objective, and alternative course of action. In case the present solution or present plan of action fail to uh, give the proper results, that is very important. Next, construction of a model. After formulating a problem, the next step is to construct the mode. The mathematical model consists of equation which describe the problem. The equation represent effectiveness function or objective function, constraint or restrictions, and the objective function and constraints are functions of two types of variables: control variables, uncontrollable variables. And now generally any problem with, there will be an objective function that objective function has to be solved within the constraints or within the restrictions. So there may be 2 or 3 restrictions, depends on the particular problem, and we have to solve the particular uh, objective function, and to find we have to find an optimal solution for the objective function within the constraints that are provided in the particular case. So the objective functions or constraints are functions of 2 types of variables: controllable variable, uncontrollable variable. So during the process of finding an optimal solution for the objective function, there will be variables, controllable variables, uncontrollable variables. So you have to balance these 2 things, and therefore you have to go for the solution. You have to find out the solution for the particular problem. Next on the medium-sized linear programming model with the 50 decision variables and 25 constraints will have over 1300 data elements which must be defined. So this is a very lengthier problem. So such a uh, variables, constraints, and all these things, it is difficult to, it is very difficult to define first initially. Difficult to define the objective function, difficult to define the constraints, and it can be divided into 2 or 3 components, and therefore it can be solved out. Next comes to uh, deriving solutions from the model. An optimal solution for a model consists of 2 types of procedures: analytical model, numerical model. Analytical model and numerical model procedures make use of 2 types: the variable branches of mathematics such as calculus and matrix algebra. Numerical procedure consists of trying various values of controllable variables in the mode, comparing the results obtained, and selecting that set of values of these variables which gives the best solution. So uh, how to derive a solution for a particular model? There are so many models are there: analytical models, numerical models, all those things. And in all these things, some can be calculated through certain algebra, some can be calculated through calculus. And whereas this operation research is a different one, there will be some variables, and within the variables and within the controls constraints, you have to solve the particular problem. Next, the fourth comes to the testing the model. A model is never a perfect representation of reality, but if properly formulated and correctly manipulated, it may be useful predicting the effect of changes in control variables on the overall system. So generally, it is a usual procedure to formulate a particular model, and within the boundaries of the constraints, we are going to solve the particular problem and try to find out an optimal solution. So that is, with that particular model, you will arrive at a particular solution. That may not be, it may be optimum as per the model, but it may not be the perfect solution for that. If you go for some other model, it may give some other optimal solution, so which may be better than this particular previous solution. So like that, any model cannot give a perfect real model or a very optimal solution. But it gives a representation to solve the particular problems. So like that, different models will give you different solutions, and from that you can select one best optimal solution. uh, so like that, you can go ahead for the particular thing. Next comes to establishing controls or solution. A solution derived from a model remains a solution only so long as the controlled variable retain their values and the relationship between the variable does not change. So a solution derived from a model remains a solution only as long as the uncontrollable variable retain their variables values and the relationship between the variable does not change. So if the relation between the variables does not change, and then can be, we can control the particular overall solution for the particular problem. So if the variables are changing, so you cannot control the particular solution. So that is the particular thing. Next comes to implementation. War is not merely war is not merely to produce a report or to improve the system performance, the result of the research. So it is not a report to improve the system performance. It is the result of the particular research. It is the result of the optimal solution. So it is not a final report, which through which you can conclude, through which you cannot conclude. So therefore, it gives a basic idea for your problems. That's all. Next comes to additional changes or modification to be made on the part of war group, because many times solutions which took feasible as paper may conflict, feasible on paper may conflict with the capabilities of the ideas of the person. Now, with an optimal solution for a particular problem, you will arrive at a particular solution, and so that may not be exactly reflect the offshore problems or the on-site problems of the uh, particular production in a unit. So therefore, it gives. So therefore, the solutions that you got on paper may not have exactly reflect the actual problems. So it gives a basic idea on it. Limitations of war. Mathematical models, which are the essence of war, do not take into account qualitative factors or emotional factors. Mathematical models, which are essential, are essential essence of the war. So there are so many mathematical models. They are the essence of the operation research. Do not take into account the quantitative factor, emotional factors. Quantitative factors means this is the uh, production of a particular factory in numbers, or the emotional factors of the environment or the persons that are involved in the particular thing. So that is the particular thing. Next, the mathematical models are applicable only specific categories of the problems. So the mathematical models are applicable only for specific categories of the problems. Next down comes to being a new field. Being a new field, there is a resistance from the employees for the new proposals. Management may offer a lot of resistance due to conventional thinking. War is meant for men, not for that man is meant for it. So it is a new field, hence there may be resistance from the employees for the new proposals because they have their apprehensions. Management may offer a lot of resistance due to conventional thinking. So in this because we are finding out a solution on the lines of the mathematical models. Management may not prefer the or consider the particular solutions. War is meant for man, not for the that man is meant for it. So the main solutions are mathematical solutions are meant for the persons involved in the particular thing to arrive at particular solutions. Whereas the persons who working in the factory, they do not consider, and the operations research is not for the particular persons who are working in the particular factory. So it is for operations research only meant for the top people. So next comes to difficulties of war, the problem for formulation phase, data collection, operation, analysis. Analyst is based on the observation in the past. Observations can never be more than a simple of the whole problem. Good solution to the problem at the right time may be much more useful than perfect solution. So the initially for any model, you have to formulate the particular problem. So that is the objective function you have to describe with the help of certain constraints. The objective function has to be defined by yourself. The constraints are to be defined yourself. Depends on the particular situation of the factor. Next, to aim at the particular solution, data collection is also very important. Data collection at various points of the particular factor is very important. Operations analyst is based on his observations in the past. So who is analyzing in the particular case, who is analyzing the solutions, who is analyzing the entire situation, who is analyzing the entire data, mainly based on his the past experience. Observations can never be more than a sample of the whole. So one sample of the entire lot can be considered, uh, but it cannot be give a particular complete solution. So observations ought to be carried out at various areas, and thereby finally the concerned analyst has to arrive at a particular solution. So next, good solution to the problem at the right time may be much more useful than perfect solutions. Good solution to the problem at the right time may be much more useful than a perfect solution. So, if you are able to give the solution to the problems faced by the factory at a particular right time, so automatically you will get a good solution for the particular problem at the right time. So if you give the solution after the problem is over, then therefore there will not be usage with the particular thing. Next comes to linear programming. This is a particular problem, LPP, what we are going to call it as linear programming problem. So in that there is a simplex method and a big M method, all those things are there. So requirements of linear programming. So there must be a well-defined objective function, which is to be either maximized or minimized, and which can be expressed as a linear function of the decision variables. So generally, we have to formulate an objective function. For that, you have to define whether it is to be maximized or whether it is to be minimized. So minimize so and so like that, he will be given, it will be formulated, or maximize so and so, it will be formulated by taking all the factors into consideration. So at the same time, you have to define the constraints for that particular also. A large objective function is there. So followed by two or three constraints, the less than or equal to, or greater than or equal to, or sometimes equal to, like that constraints will be there. And we have to convert the constraints into by adding slack variables or surplus variables into the to solve the uh, particular objective function in the form of identifying an optimal solution. There may be constraints on the moment of extent of the capable of being expressed as a linear equalities in terms of variable. So I told you just now, there must be constraints on the amount of extent of B capable of being expressed as linear equalities in terms of variables. So constraints must be there, and there must be alternative course of action. So if you are able to arrive at a particular solution, and if the solution is not feasible sometimes, if the solution is not feasible sometimes, then you have to find out what is the alternative course of action, how to solve it, how to find an alternate solution for this. That must be decided in advance. So if you are able to arrive at an optimal solution, it's well and good. If you are unable to arrive at an optimal solution, and if the solution found is also not feasible, then you have to see that the alternate course of action. Next comes to the decision variable should be interrelated and non-negative. The decision variable should be interrelated and non-negative. So non-negative means if it is a negative, it will give a particular answer for that. If it is a non-negative, it will give another solution for that. By arriving, if the if their decision variables are negative, then we can interpret the solution in a particular manner. If the non-negative, we can interpret the solution as in a different manner. The resource must be limited. The resource must be limited means all the resources must be limited. Next, some important insight into the particular thing. The power of variable and products are not permissible in the objective function as well as constraints. The power of the variables and products are not permissible in the objective function as well as constraints. Only in this particular case, if you formulate in a particular objective function, you are going to denote them as x1, x2, x3 like that. So therefore, the actual product, so X1 is named in the name of certain product. X2 is named in the name of some other product. So therefore, that influence of the product will be avoided by naming them as X1, X2, X3, etc. So like that. Next, linearity can be characterized by certain additive and multiplicative properties. So additive example, if a machine process job A in 5 hours and job B in 10 hours, then the time taken process both the jobs is 15 hours. This is, however, true only when the change over time is negligible. Now, there is a particular component with the threads, all those things. That particular component can process the particular job A in 5 hours. Similarly, there is another job which is somewhat difficult, which is with so many operations. That is the job B, it will take 10 hours. Now, after completing there is installation time on the job, installation on time on the machine, and after that you have to keep the machine idle for some time. This idle time, installation time, and all those things are to be removed. Actual time is 5 hours. Similarly, for a job, it is in between this loading, unloading of job A and job B, there may be some time. That time should not be taken into consideration. So therefore, the effective time is 15 hours. It indicates like that it is nothing but like that we have to see the particular thing. So this is a multiplicative example. If a product yields a profit of rupees 10, then the profit and for the sale of 12 such products will be rupees 10 into 12, 120. This may not be always be true because of quantity discount. So if you allow the discount, you may not get the particular product. Next, the decision variables are restricted to have integral values. Uh, the objective function does not involve any constraint time. So you see that this is a particular objective function. You will not, the optimal values are just independent of any constraint C, what he has mentioned. So the objective function does not involve any constant terms. That indicates all these things, all the numerical variables are to be assumed and they are to be filled out. Example and formulation of lean programming model. And so production allocation problem, a firm produces 3 products. These products are processed on 3 different machines. The time required to manufacture 1 unit of each of the product and the daily capacity of the 3 machines are given in the table below. So this is M1, M2, M3 machines. So product 1, product 2, product 3, product 1, 2 hours, 3 hours, totally 2 hours like this. Whereas it is 4 hours, product 1 is another product. So like that, minutes per day. So maximum capacity. So minutes per day is. It is required to determine the daily number of units to be manufactured for each product. The profit per unit for a product 1, 2, and 3 is rupees 3, and rupees 6 respectively. So this is rupees 4 is for 1, rupees 3 is for second product, rupees 4 is for product number 3. So respectively, it is assumed that all the amount produced are consumed in the market. So basically, this is the information you got. You have to define a particular, formulate a particular problem. Formulation of the Riemann program model, step one. The key decision to be made is determine the daily number of units to be manufactured for each product. So we have to determine the daily number of units to be manufactured for each product. So how many units are to be produced, that is very important. That X1, X2, X3, with the number of units of the products 1, 2, 3 manufactured daily, feasible alternatives are the sets of values of X1, X2, X3, where X1, X2, X3 greater than or equal to 0, since negative number of production runs has no meaning and is not finished. So always it should be greater than 0. So production will be not be negative, isn't it? So next, fourth one, the objective is to maximize the profit. That is the maximize. So in this particular case, we have to maximize the profit, means maximize the production. So hence, in formulating the particular problem, now we have to use the word maximize, that is equal to 4x1 plus 3x2 plus 6x3. 4x1 plus 6x2 and 3x2 plus 6x3. So this is the way we formulated the particular thing. Next comes to, so 4x1 and this is 3x2 and 6x3 like that. 4x1, 3x2 plus 6x3. So like that, the costs were involved in the maximize the particular thing. Now express the constraints. What are the constraints that are, how to formulate the constraints? 2x1 plus 3x2 plus 3x3 less than or equal to 440. If you go to the first row, please go to the first row. 2x1 plus 3x2 and 2x1 plus 3x2 plus 2x3 and 440. So that's why less than or equal to 440. So total consume combined together. So this is the way we have formulated the particular constraint. Second one, 4x1, 0x2 plus 3x3. So 4x1, there is no variable in this. So 0x2 plus 3x3 less than or equal to 470. Next, similarly, this is 2x1 plus 5x2 and 0x3 less than or equal to 430. 2x1 plus 5x2. 2x1 plus 5x2, 0x3 less than or equal to 430. Like this, we have formulated the objective function. Maximize z is equal to this is. These are the constraints what we have formed. Now we have to find out the optimal solution with a particular thing. Next comes to advertising media section problem. This is another problem. So another problem, nothing but the linear problem. An advertising company wishes to plan is advertising strategy in 3 different media: television, radio, and magazines. So the purpose of advertising is to reach as large as a number of potential customers as possible. Following data has been obtained from market survey. From market survey, you got this particular thing. So this is cost of an advertising unit. Cost of a television law in the television, the advertisement costs 30,000, radio 20,000, magazine 115,000, magazine to 10,000. Next comes to number of potential customers. So how many customers we can reach? The advertisement can reach through television means it is nearly 2 lakhs. So it is 6 lakhs, it is 1,50,000, it is 1 lakh. The advertisement can reach. So number of female customers reached per unit. So number of female customers means 1,50,000, 4 lakhs, and 70,000 in case of magazine 1, so 50,000 in case of magazine 2. So therefore, the company wants to spend not more than 4,50,000 rupees on advertising. Following are the further requirements that must be met. So totally, the company would like to spend 4,50,000. So this is the market survey. So this at least 1 million exposures takes place among female customers. At least 1 million exposure takes place among female customers. Second one, advertising and magazines be limited to 1,50,000, and at least 3 advertising units must be brought on Aximize on magazines 1 and 2 units, 1 and 2 units on magazine 2, and the number of advertising units on television and radio should each be between 5 and 10 formulations and LP for the particular problem. So these are the here all these things are nothing but the conditions. All these things are nothing but the conditions that are given to formulate a particular solution, to formulate the objective function as well as the constraints. So here the solution, the objective function is to maximize total number of potential customers. Maximize means the advertisement has to reach a maximum number of people. The advertisement has to reach maximum number of people, either via television, via radio, via magazine 1, via magazine 2. So therefore, this maximize z is equal to maximize z. So this is nothing but the objective function. So in this, you can see that 2x1, 6x2, 1.5x3 plus x4. So you go to the first table. So depends on that. So 2x1 So this is the number of potential customers. So this is 2, 6, 1.5, 1, 6, 1.51. So this is the maximize, that is equal to 2, 6, 1.5 and 1. You can see this particular thing, 2, 6, 1.51, 1. So this is the related to objective function into 10 to the power of 5 means, because there are multiple variables are there. On the advertising budget, these are nothing but the constraints. 3,000, 30,000 x1, 20,000 x2, 15,000 x3, 10,000 x3. So like that, 4,50,000. So less than or equal to, this is nothing but, so 4,50,000, 4,50,000 he has given. So that's why it should not be greater than. So less than or equal to 4,50,000. On number of female, so number of female customers 1.5 x1, 4 x2, and 0.7 x3, 0.5 x4, like that. So you can see that number of female 1.5, 1,50,000 he has given, 4,50,000 and 70,000, 50,000 x4, and greater than or equal to this thing. And similarly on the expense on magazine, cost of advertising, 30,000, 20,000, 15,000, like this. So 30,000 on the expense of the magazine. So you can go for this particular thing, and the expense of the cost of advertising particular thing. So 1.5, 10,000, 15,000, 10,000, and expenses. Now you can, the advertising and magazine is limited to 1,50,000. So at least 3 advertising units. So depends on that, he has formulated the expense of the, on the number of units of the magazine, x3 greater than should be 4, x4 should not be greater than or equal to 2, 5 less than or equal to 2, less than or equal to 10, 5 less than. So like this, depends on the constraint, depends on the definitions that are given. So similarly, like that, we have to formulate the problem. All these are nothing but the constraints, and maximize that is equal to the objective function. You have to solve the particular problem. So similarly, example 3. A company has 2 grades of inspections, all these things. And in this, let x1, x2, x3, inspector of grade 1 and 2. So depends on the problem, simply you can formulate the z is equal to like this. So these are the constraints and the final constraints, and there are totally all these constraints are to be adopted to solve the particular problem of the objective function. Example 4, an oil company produces 2 grades of gasoline, P and Q, which it sells at rupees 3 and rupees 4 per liter. The refiner can buy 4 different codes in each other. So this is 1, 2, 3, 4 different 4 grades. This is 0.75, like this. There is constants are given, price per liter, and he has also given, and rupees 3 grade must have at least 50% of A and not more than 40% of C. The rupees 4 grade uh, must not have this thing. He has given like this. So he has assumed that like X1P amount of crude 1 used for the gasoline P, and X2P, X3P, like this. Depends on the problem. He has assumed, he has formulated the particular thing. After this, he has gone for the uh, maximize here. He has formulated an objective function, and he has formulated a the particular constraints for the particular thing. Depends on the particular table, depends on the uh, conditions that are given. So conditions that are given in the particular table, we can go for like that. And similarly, this is another problem. A person wants to decide the constituent of a diet which will fulfill his daily requirements of proteins, fats, and carbohydrates at the minimum cost. The choice is to be made from 4 different types of foods. The yields per unit of these foods are given below. So, in this particular thing, a person wants to decide constant of a diet, fulfills daily proteins, fats, proteins, fats, and carbohydrates, the minimum cost. So 4 different types of foods. 1, 2, 3. There are 4 different types of foods, and first food will consist of 3 proteins, 2 fats, 6 carbohydrates, and cost of the unit is nothing but the cost per unit is nothing but the 45. Whether what can be taken be. Similarly, food type 2, like that. So maximum minimum requirement is 800, fats 200, all these things, and formulate the linear programming model for this particular problem. So the objective is to minimize the cost. Minimize the cost means, so he has taking varied types of food, 4 types of foods. Out of the 4 foods, he has to reduce the cost while purchasing. So therefore, minimize. We have to give minimize. So therefore, minimize that is equal to rupees. So he has given 45x1 and 40x2 and 85x3, 65x4. So these are the various costs. So this is the food 1, food 2, food 3, food 4. So like that, minimize the constraints are given for proteins. For proteins, 3x1, 4x2 plus 8x3 and 6x4, and should not be less than or greater than or equal to 800. Similarly, next one, 2x1 plus 2x2 plus 7x3 plus 5x4 should not be greater than or equal to 200. Minimum, this is the minimum requirement, should not be, sorry, greater than or equal to 200. And similarly, for carbohydrates, it is the same case. 6x1, 4, 7, and lastly, 4x4 greater than or equal to 700. 700 is the minimum requirement, 200 is the minimum requirement, and 800 is the minimum requirement. So everything should be, all these things should be greater than this 800. So like that, the objective function along with the constraints is formulated. So this is the another example. So this is another example 6. There is a table in this particular case. So they based on that, there are 2 tables are there, and depends on that objective function as well as the constraints are formulated, and is there next. Similarly, example 7, a paper mill produces rolls 100 mm length, and thus the company must cut its cutting alternatives as follows. So like that, roll width demand. So this is a particular roll width, 2 centimeters, 4 centimeters, 6 centimeters, 10 centimeters. So depends on that. Is 2 centimeters. This is greater than or equal to 2000. He has given greater than 3600, greater than 1600. All these things. So like this, we have to formulate. So this is another solution, graphical solution method. The collection of uh, the collection of all feasible solutions to an LP problem constitutes a convex set which whose extreme point corresponds to the basic feasible solutions. There are a finite number of basic feasible solutions within the feasible solution space. If the convex set of feasible solutions of the system AX is equal to B, X greater than or equal to 0 is a convex polyhedron, then so for a graphical solution, so uh, there are certain difficulties in formulating the problem, but once if you are able to formulate the graphical solution, identify the particular solution, it is able to solve the particular problem very easily. So in this particular things, the constraints are less than or equal to, and constraints may be sometimes greater than or equal to. And you have to draw a graph, so between the X and Y, and identify the points. So if the greater than means, first of all, there may be two variables only, x1 and x2. If x1 is equal to 0, x2 is equal to what? If x2 is equal to 0, what is x1? So like that, you have to identify the points. After identifying the points, you have to enter them in the graph for the particular for the particular equation. So if the particular equation is greater than or equal to something like that, you have to hatch above the particular line. So if the equation is less than or equal to, you have to hatch below the graphical line. So like that, two equations. So similarly, you have to find out another set of points for the second constraint. And therefore, depends on the points on the x-axis and y-axis, you have to draw the line. If it is greater than, you have to hatch above it. And if it is less than, you have to hatch below it. So the area which is not intersecting is going to be called as the feasible region. Like that, you have to identify the particular problem, feasible region, and feasible solution for the particular problem. So extreme point enumeration approach. Extreme point enumeration approach. This is the solution method for an LP problem is divided into 5 steps. Step 1. State the given problem in the mathematical form as illustrated in the previous chapter. So I told you that is basic equation. Basic equations means, so that is maximize or minimize. Like that, you have to state the particular problem. Next, second one is graph the constraints by temporarily ignoring the inequality sign. I just told you x1 is equal to 0 and what is x2, and x2 is equal to 0, what is x1, and decide about the area of feasible solutions according to the inequality sign of the constraints. Indicate the area of feasible solutions by a shaded area which forms a convex polyhedron. So greater than means above the line, less than means below the line. You have to hatch it and find out the indicate the area of a feasible solution by a shaded area which forms the convex polyhedron. Determine the coordinates of the extreme points of the feasible solution space. And for that particular feasible solution, you have to find out the extreme points, bottommost point and topmost point. So because both the lines are intersecting, and therefore you have to identify the coordinates. There may be 2 coordinates, there may be 4 coordinates, including the origin. You have to find out the points. So determine the coordinates. Coordinates, you have to identify the 4 coordinates of the, evaluate the value of the objective function at extreme point. Evaluate the objective of the objective function at an extreme point. So therefore you have to evaluate the objective function, determine the extreme point to obtain the optimal value of the objective function. Determine the extreme point. You have to find out the top point and you have to find out the bottom point. Types of graphical solution: single solution, unique solution, unbounded solution, multiple solution, infeasible solutions. So these are the different solutions, depends on the particular problem, depends on the greater than, depends on the grade. So here it is greater than, here it is less than, less than, less than. So like this is the graphical solution. And I told you, so step 1, step 2. So this is a particular thing. I told you for the particular 4x1 plus 6x2 less than or equal to 360. So if x1 is equal to 0, x2 is equal to. So in this, if x1 is equal to 0, 6x2 is equal to 360. Therefore, x2 is equal to 60. And similarly, x2 is equal to 0, and therefore 4x1 is equal to 360. So the x1 is equal to 360 by 4. You will get 90. So 0, 60 and 90, 0. You have to identify the line. And this is less than or equal to, you have to hatch below. So similarly, the constraint 3x1 less than or equal to 180, 5x2 less than or equal to 200. So, okay, 3x1 less than or equal to 180, 5x2 less than. So, therefore, x2 is equal to 200 by 5 and x1 is equal to 180 by 3. So, like this, because both are nothing but less than 180, less than 200. So, less than 180 means a vertical line, the horizontal line, you will get it. So, below that, you have to hatch it. So, finally, you will see that. So, the optimal solution. So, 0, 4, 0, 30, 40, and this is the particular. So determine the coordinates of the extreme points as given. Determine the coordinates of the extreme points. So you have to see the extreme points of the particular coordinates. A, B, C, D. So these are the extreme points. A, B, C, D. A, B, C, D. This is all, everything is less than. Finally, this is the feasible region, because this is the feasible. Less than means for the vertical line, less than means left side. And again, for this 0, 40 line, less than means below this particular line. And again, for this means, this is the less than means this particular region. So this is the region bounded by the three lines. Bounded by the three lines, nothing but 3x1 less than 150 and 5x2 less than 200, all those things. And like that, so in this 0, A, B, C, D. 5 points are there. 0, 0, 60, 0, and 60, 20, and 30, 40, 0, 40. So like that, these are the various points. So objective function z is equal to 15x1 plus x2, sin x2. So initially we have formulated an objective function. So that is nothing but 4x1, sorry, objective function 15x1 plus 10x2. This is objective function as given. So 15x1 plus 10x2, all these points are to be submitted in this particular equation. All the points are to be submitted in this particular equation. So 15x1, if you submit these points, 0, 0 means you will get 0. 60, 0 means you will get 900. So 60, 20, you will get 1100. And 30, 40, if you submit, and you will get 850. And 0, 40 means 400. So like this, you will get the particular thing. Z is equal to, among all the things, Z is equal to 1100. So our problem is a maximization problem. So maximize Z is equal to, because it is a maximization problem, and you have to see that what the maximum value in this particular table. In this particular table, 1100 is the maximum value. So that is equal to that is equal to 1100 at point B. So this is the solution. So you have to show like that. And single bounded solution.
ఫోన్లో చాటింగ్ ఎవరంటే ఇప్పుడు వరకు సమాధానం ఎప్పుడన్నా అడిగాడా నీకు ఆ విషయము? అడగడు అలాంటివి. ఎవరితో చాటింగ్ చేస్తున్నావు అంటే నీకు ఎప్పుడన్నా అడిగాడు అసలు?
దాంట్లో 50 గ్రూపులు ఉన్నాయి.
చెప్పు ఆయనకి, చెప్పితే అప్పుడు వెంటనే
So this is a single bond solutions. There is another problem. This particular thing. Maximize Z is equal to 5x1 plus 3x2, subject to the constant 3x1 plus 5x2 is equal to 15. X1 plus x2 is equal to x1 plus 2x2 is equal to 10. I told you to find out the points for this particular x1 is equal to 0 means x2 is equal to 3. So therefore 0, 3, x2 is equal to 0 means 3x1 is equal to 15, x1 is equal to 5. So therefore 5, 0 are the points. So depends on the particular points, you have to draw the line. So this is the line for the particular equation, first equation. Second equation you have to find out. For the same second equation, that is x1 plus 2x2 is equal to 10. So this is so here it is 5x1 plus 2x. So there should be 5x1 plus 2x2 equal to 10. There's a controversy in this particular case. So like that, you have to find out, to draw the lines, identify the points, nothing but you have to identify the points for the ordinates. What I mean, it is nothing but the ordinates, x ordinate and y ordinate points, and draw lines, vertical lines. So if it is equal to, it is equal to. Equal to means, therefore you cannot do anything particular case. So therefore here he has not given either greater than or less than. Therefore unbounded solution means feasible region consists of a single point A. Feasible region consists of a single point A. He has not given either less than, or he has not given either less than or greater than. So therefore you cannot hatch either above the particular lines or below the lines. So therefore A is the feasible region point, what we can call it as a single. So for this you have to find out the horizontal coordinates and vertical coordinates. So actually what you have to do in the exam, you have to take out a graph sheet, you have to draw the particular the equations by identifying the points, and thereby you can exactly locate the particular thing. So like this, you have to, this is going to be called as the particular thing. This is another equation, unbounded solution, and multiple solutions you will get in this particular case. And okay, this is a linear programming problem. We'll discuss in the next class. Today, you have to go for some other classes, isn't it? And I'm winding up the particular topic up to this particular point. My time is over, and you have to go for the, I hope that. And what I observed that some students are entering at the end of the class just now. So this is very unfortunate. I request all of you to attend the class from the beginning to the end. So it is easy for me to explain, but it is very difficult to follow these online classes. That too, it is a problematic solution. It is a problematic solution, and so you have to be very careful.
Warna itu,